What's up everybody, the Network Berg here. I hope you're doing well. In today's video we'll be discussing OSPF on a MikroTik router. It's pretty straightforward actually. If you look at this diagram, it looks a bit hectic. I don't want things like a network diagram to scare you into learning networking. But it is something that you'll have to get used to. So whenever you look at a diagram like this, try and tackle it as logically as possible. Just look at what routers there are, how they're all connected, and if there's any IP address information between these routers, because it's actually just showing you how everything's connecting. It's not really showing you the solution as a whole. So just something to take note of. So whenever I need to look at a router, I'll just look at the interfaces and try and figure out how everything's actually connecting. You'll see I did add a switch here. The switch, it has nothing to do with OSPF. This is just for me to quickly manage these routers and set them up and configure them so that we can do it very quickly. I didn't want to struggle and make it a hassle. So I just added like a management range on all of the port 10s of these devices, and there's some management IPs that I can get to them from my computer. So back to the topic, OSPF, what is it? It is an IGP, an interior gateway protocol. Typically what an IGP is, it is a routing or a dynamic routing protocol that works within its own autonomous system. So this is something that you would use in your own network. This isn't something that you would use to be peering with another provider. That is something that you'd use like BGP for. OSPF, we use that locally. It works great in the enterprise. It works great for small ISPs. And when you start moving to some bigger ISP territory, you might see something like ISIS in order to do that internal routing for you. So OSPF is also a link state routing protocol. So it will look at all of the links or all of the interfaces that is coming in that you've configured, where it is broadcasting its hello messages out of in order to form adjacencies or neighborships with other routers. And then it will learn the best path through the network by looking at things like costs and bandwidth and all kinds of cool stuff like that. So we've got a basic topology here. There's area 0000 or area 0. That's always going to be your backbone. So area 0 always needs to learn all of the different routes. It's kind of the main routing table if you think about it. And we can split OSPF into smaller areas like area, do you see area 1 or area 2? I'll just hover my mouse there, where you can limit the amount of link state updates being broadcasted inside the area. So let's say if you only used area 0, what happens if you have 1,000 routers? They would flood each other with broadcast traffic, and it could potentially down your own network just by routers sending each other hello updates and LSUs and stuff like that. It's really not best practice to do that. However, if you split it up into smaller areas, it will only keep those broadcasts within that area. So not all the routers will keep talking to each other and learning all of the best paths. Only the routers within the areas will learn their relevant routes. And then you'll see like this router in the middle, that will then bring it into area 0, limiting the amount of broadcast traffic then. So in OSPF, you typically get 3 different types of routers. The one is an IR or an internal router that you can think of the last mile or the edge, where you're going to stop running your OSPF, or not stop running it, but there's not going to be typically another router that you're going to connect into a different area from here. If you do that, then that router automatically becomes an ABR or an area border router. So this is like this ABR1 or ABR2. So this is a router that exists inside both areas. It will learn the routes of area 00 or 02, and it will learn the routes of area 0, but it will bring the routes of area 2 into area 0, and vice versa. It will bring those routes it learns from area 0 into area 2 as well. So it's just a router that's between the areas. And then lastly, you'll get an ASBR or autonomous system border router. So that would typically be a router on your edge somewhere that's peering with, let's say, an internet service provider, and you're learning your internet routes or external networks through this router. So the external networks will still come into the router, but that part that's EGP. That's not going to be IGP. But we call it an ASPR because it exists on your edge, connecting to different routers, but it's still learning your internal routes. So you might see that at your edge where, like I said, we're connecting with your ISP. That's the base of OSPF actually. So now that we've done the logic, let's quickly do the configuration. So I've already configured all of these routers. They all have OSPF running and it's working and it's great and it's good. But me showing you that OSPF is running and working doesn't necessarily show you anything. So what I'm quickly going to do is I'm going to spin up a new router for you. Let's just find a MikroTik here. I'll call this R2. No, R. Yeah, we can use R2. R2 is not being used. I might just move this a little bit for my own sanity. And I'm also just going to connect this router into the switch quickly. Actually, we need to connect the router to some of the other routers. So let's maybe connect it to ABR1 on Ether 3 and router 1 on Ether 3. So let's do it that way. Just make it look a little neater. Doesn't matter too much. We already know which ports goes where. And then port 10, I'm just going to bring into my management as well. So we can quickly get there. I'm going to turn the router on. And then we're going to configure an IP address on it quickly. Let's get in there. Admin blank. So you see this is a blank router in its default state. Nothing's happening here. IP address. Add address. So this is again just the management route. Ether 10. So now I can go into my Winbox, and we can do this through the command line as well. I just choose to do it through Winbox because it is relatively straightforward on MikroTik's Winbox. So we've got Winbox open. We're on that new router we created. So in order to do the OSPF, we need to go into the routing tab. We go into OSPF. First thing we do is we can add our instances, but there's already going to be an instance, and this should be your backbone. So this will be here by default. You can't delete this. It will always be here. It's always good to set a router ID because this identifies, think of this as your name in the routing process. So typically what you do is you'd either give this like a loopback address, or you could potentially give it one of your WAN IPs or something that you know another router on the network isn't going to have. So I might just make this, let's just make it 7.7.7, no actually 8.8.8.8.9, because I don't want that Google's DNS to be an issue. Okay, I cancel that by accident. Let's just quickly create a loopback address. So we can do that by adding a bridge, call it allo1, and assign that same IP address to that bridge. 8.8.8.9. My fingers are so quick to type Google's DNS. Apply. So now I just quickly need to set up IP addresses between this new router we set up and the two other routers, because they need to be able to communicate with each other directly. So let's just do that. I did connect Ether 1 into the ABR. So let's just give it a IP address of, I'll just make it 10.3.0.1/30, and then 10.3.0.5/30. And I just need to assign the same IPs to the other routers quickly. So that should be .3. Just want to make sure this is the right router. It looks like it is, so let me just quickly add the address. And this came onto Ether 3. So that will make .2. Just need to enable it. Sorry, I disabled these interfaces in my lab. And I need to do the same on router 1, or we can think of that as the provider router or the core router. Same thing, enable ether 3, add an IP address. And I don't want the IPs to confuse you. They could have already been pre-set up, like a lot of your networks might be, and you're just thinking to bring OSPF online in order to dynamically start routing your routes instead of having to manually or statically put everything in, because that's such a mission, isn't it? Okay, so I've added my address, but that isn't a right address. It should be .6. Okay. So I should now be able to reach 10.3.0.5, correct? And let's just go to the ABR, and this one should be able to reach 10.3.0.2. Okay, cool. So we do have IP connectivity between our routers. So this new router we brought in, it can talk to router 1 and the ABR or whatnot. Let's just quickly set up the OSPF again now. So let's go back into our new router. We have our loopback address. We've got IP addresses that can communicate across the network. So let's go into the OSPF. So to do it on MikroTik, very straightforward. And this is also an automatic process the first time, like you'll see what I'm talking about now. So if we click on the plus, if I add that 10.3.0.0/30 on the backbone, and I add 10.3.0.4/30, no, yes, no, that's right. Then we are going to start seeing it is running now. And if I go to my interfaces, which was blank when we went in here, it created two dynamic interfaces, ether 1 and ether 2, which are the interfaces that's connecting to the other routers. So they're currently in a waiting state. Reason being is I haven't set the networks up on the remote router, so it's not sending out hello packets on router 1 or the ABR. So let's just quickly do that. OSPF. So this should be, that's router 1, so it's this one. And let's go into router or the ABR, routing OSPF networks. Same thing will apply on this router. You'll see ether 3 became a dynamic interface, but I'll go to our new router that we created, and the OSPF has connected. The new router went into the DR or designated router state. So think of this, it's just like, is it a primary or backup or whatever router? But we'll change this right now because I tend to like to use point to multi-point whenever I do a setup. And I don't like using the dynamic interfaces either. So to change it, just double click on the interface, copy it. Same values, except the network type, we're going to switch to point to multi-point. And all these other values, you can change them as much as you want. It will have a change on how this router distributes its routes to the other routers. So if you increase this cost, it will make the routes cost more in order to get here to this router. Okay, point to multi-point, I've set this. I just want to set it on all of them quickly. And it's very quickly to do, as you can see. So same thing here. Copy point to multi-point. And then the last one, copy point to multi-point. Okay. So now I have all these interfaces configured for OSPF, and it is running. So let me just go back to our new little router. It is set up, it is running. So if I go to my neighbors tab, I can see which neighbors I have, what their router IDs are, what their addresses are that I'm connecting to them, which interfaces they're on, and how many times the link state has changed. So this can be any updates that are sent throughout the network. If it goes down maybe, or if there's some issue, this state value changes. We can go into our routes, and then here we can see which routes we are learning. So these are all of the OSPF routes that are being sent through the network. These are all of the addresses. These gateways just tells our router how to get to them. And here's the interfaces it's learned it, as well as what the cost is. So it's just like static routing, where you define a cost. It's going to take this much to get to that network, right? You'll see the state. The state is also important. So you'll get 3 different states in OSPF on MikroTik. The one is intra area. So those are routes or routes that are learned inside your area. So routes that are learned inside area 0, the backbone. Inter area are routes that are learned in a different area, inside area 1 or area 2. In order to create a new area, it's pretty straightforward. I'll do the creation. So you click on the plus, and then from here, actually let's just jump back into GNS3. I'll go into this ABR and show you. We had it open, the ABR. Let's go into the ABR. So if we go into our routes and we go into the OSPF, when we go into the areas, you'll see I've already defined area 0, 0 here. To add the area, obviously you just click on the plus, call it whatever you want. You might call it a customer name or area 01, whatever you're comfortable with. The instance, that's just, remember the start where we had our instances where we defined the router ID. That's what this instance is referring to. So in that instance, you could also use a different routing table, which is quite nice. Area ID, so this is the important bit. So here you can make it like area 1 or 2 or 10 or 100. And that's it. You can set the type as well. Generally, you're going to leave it as default. We hit apply. And then I've got an area 100 here. So when we defined the networks earlier to start that OSPF communication, here you see I've got area 01 defined. So if I wanted to bring this into a different area, I would just connect it on area 0 there, and I would put the network that I want to broadcast inside that area. So let's go back to our new router. I just want to broadcast our route out quickly to the rest of the network. Because if I go into, let's say, router 1, you remember on the new router we have an 8.8.8.9 loopback address. If I go into my routes, I suspect that I do not have that route. As you can see, I do not have it. So let's quickly send that route throughout the network. So I'm going to go back onto the new router. When we go into the networks, we can click on the plus here again. And I'm going to say I'm going to broadcast 8.8.8.9. I hit apply. Now let's go back to router 1. And router 1 is that router at the top. So router 1, it's learning 8.8.8.9 from, it knows how to get there on .5. And if I go into my routing, OSPF, and I go look at the routes again, you'll see there it's learning it, and it learns how to get there. So that is OSPF in a nutshell. It's a routing protocol that will make your life a lot easier once you implement it inside your network, especially, like I said, if you're a small ISP. It'll save you so much time, and there's so many different things that you can do. I could probably rant on for a good couple of hours on the different types of configurations you can run on OSPF, how you could redistribute your routes into different routing protocols as well. It's really an interesting subject, routing in general. I hope this wasn't too confusing for you. If it was, I can make a follow-up video. I just wanted to show you how to set up OSPF on a MikroTik router and how it works. I hope this has been informative, and I'd like to thank you for watching. If you haven't subscribed to the channel, please consider doing it. It does help grow it, and consider sharing this with your friends. If you know anybody that wants to get into networking, I appreciate it so much. Thanks again.